This is a lesson summary video for the lesson titled Proof Practice. This is a practice understanding task. The purpose of this task is for students to practice using theorems, postulates, properties, and definitions to solve problems and prove relationships in geometric figures. Let's begin by reading through the problem. Suppose that ABCD is a parallelogram, and that M and N are the midpoints of segments A, B, and segment CD, respectively. Prove that segment MN is congruent to segment AD. Next, I want to mark the information we are given on the diagram and make a general plan for our proof. My plan is to first state that quadrilateral ADNM is a parallelogram, and since it is a parallelogram, opposite sides must be parallel and congruent. So, since ABCD is a parallelogram, we know that opposite sides of the parallelogram are congruent and parallel. That means that DC is congruent and parallel to AB. Since M and N are midpoints, they divide each side into two congruent segments. And since DC and AB are congruent, the midpoints divide them into four congruent segments, meaning specifically that DN is congruent to AM. Since segments DC and AB are parallel to each other, that means that AM and DN would also be parallel to each other since they are on segments AB and DC respectively. If we can justify that one pair of the sides of the quadrilateral is both parallel and congruent, then we know that the quadrilateral is a parallelogram. Since DN is both congruent and parallel to segment AM, ADNM is a parallelogram. Since opposite sides of the parallelogram are parallel and congruent, that means that MN is parallel and congruent to AD. Let's formalize this plan with a two-column proof. I'm going to start with the part of the given, that ABCD is a parallelogram. Since ABCD is a parallelogram, we know that opposite sides DC and AB are both parallel and congruent. Since segment DN is on segment DC and segment AM is on segment AB, we know that DN and AM would have the same slopes as DC and AB and are therefore also parallel. Remember that my goal is to first prove that quadrilateral ADMN is a parallelogram by stating that one pair of opposite sides is congruent and parallel. This statement takes care of the parallel requirement of that. Now I'm going to move on to the other part of the given, that M and N are midpoints of the segments AB and DC, respectively. This means that segment DN is congruent to segment NC, and that segment AM is congruent to segment MB. At this point, I've not yet proven that all four segments are congruent to each other. In a moment, I'll use algebra to prove why they have to be congruent to each other. The next step is used to convert these congruent statements to statements of equality. We do this so that we can write equations and use properties of equality to manipulate the equations. Since I want for my algebra to end up with stating that DN is equal to AM, I look for equations that involve these segment measurements, and I also use segment measurements that I already know are equal. I start with the segment addition postulate. Segment DN and segment NC make up segment DC. In the same way, the measure of segment AM plus the measure of segment MB equals the measure of segment AB. Now we can use substitution to take these two equations and substitute equivalent values in for them. Segments DN and NC have the same measure, so I can substitute the measure of DN for NC. I can also substitute segment AM for MB and DC in for AB. This gives us two equations that are equal to DC, and the transitive property of equality tells us that if two equations are equal to the same thing, then they are equal to each other. My next step is to combine like terms and simplify my equation. Then I'm going to divide both sides of my equation by 2 and convert my statement that says that the measurements are equal to a statement that says the segments are congruent. Now that I have proven that quadrilateral ADNM has one pair of opposite sides that are both congruent and parallel, I can claim that ADNM is a parallelogram. And since ADNM is a parallelogram, I know that opposite sides must be congruent and parallel, meaning that segment MN is both parallel and congruent to segment AD. In problem 2, we were given a diagram and a short description of a couple of relationships in the diagram. We know that MNPR is a parallelogram, that segment MS bisects angle RMN, and that segment NT bisects angle MNP. We need to find the values for X and Y, and then describe the relationship between segment MS and NT. Again, let's start by marking what we know. Since MS and NT are angle bisectors, we know that angles RMS and NMS are congruent, and angles MNT and PNT are congruent. Since MNPR is a parallelogram, we know that opposite angles are congruent, so angle MNP is 110 degrees, which would make angles MNT and PNT each equal 55 degrees. We also know that consecutive angles of a parallelogram are supplementary. So angle RMN measures 180 minus 110, or 70 degrees. So angles RMS and NMS each equal 35 degrees. This also means that angle NPR is 70 degrees. Both NT and MS are transversals to parallel sides MR and NP. So alternate interior angles PNT and MNT are congruent. So angle MTN is 55 degrees. Similarly, angles TMS and NSM are congruent, so Y is equal to 35 degrees. Since 35 plus 55 is 90, the third angle in each of the triangles formed must be 90 degrees. This means that segments MS and NT are perpendicular. Let's label the intersection point of MS and NT as A. Triangle MAN is congruent to triangle MAT by angle side angle, since the two triangles share side MA. So MN and MT are congruent by CPCTC, which means X is equal to 10 centimeters. Now that we've found the values of X and Y, we need to describe the relationship between segments NT and MS. Since triangle MAN is congruent to triangle MAT, I can use CPCTC to prove that AT must be congruent to AN. I also know that triangle SAN must be congruent to triangle MAN and triangle MAT by angle side angle. This means that segment AS is congruent to segment AM by CPCTC, which remember stands for corresponding parts of congruent triangles are congruent. This means that segments MS and NT are perpendicular bisectors of each other, meaning they intersect each other through their midpoints at a 90-degree angle. In conclusion, when you're completing a proof or solving a problem involving finding missing geometric measurements, it's important to start by reading the problem carefully and then marking the diagram. With a proof, try to create an informal plan before you write a formalized proof. Okay, that's it for this video. Thank you for watching.